table, and we had to identify if the table depicted a particular function type. Okay. There are only 4 function types that we went over. Okay. One was linear function. Another one was a quadratic function. And the last one was an exponential function. Okay. Now, the linear, quadratic, and cubic functions, okay? The linear, quadratic, and cubic functions are all related. They're all related. The linear function is y equals x. The quadratic function is y equals x squared. And the cubic function is y equals x to the third. Okay? Now, an exponent is like the 5. You see the 5 and 2 to the 5th? That's an exponent. The exponent for linear functions is 1. So like if I have y equals x, there's an invisible 1, and the exponent's a 1. If you notice, the only difference between linear, quadratic, and cubic functions when you write them down is the exponent. Here we have a 1 that you can't see, a 2, and a 3. And whenever we found our table, or whenever we were given our table, we found the first difference. And if the first difference was constant, it was linear. We found the second difference. And if the second difference was constant, it was a quadratic function. And then we found the third difference. And if the third difference was constant, then it was a cubic function. Now, completely unrelated to first, second, and third differences were exponential functions. For exponential functions, we are looking for a multiplier. Okay, we're looking for a multiplier. For instance, say I had a table, xy, 1, 2, 3, 4, 5. And my first y value was 10, 30, 90, 270, and then 810. Okay. Now, the first difference we find by subtracting 30 and 10. 30 minus 10 is 20. So the first difference was 20. The next one, we subtract 90 from 30. We get 60. So next one's 60. Same thing for 270 and 90. We get, what is it, 180? And then this, we get 540. Okay? If you notice, the first difference is not constant. It's not linear. Okay? If we did the second difference wouldn't be constant either. We get 40, 120, what, 360? It's not constant either. But if we look closely, 10 to 30, that's just times 3. 30 to 90, that's just times 3. 90 to 270, times 3. And 270 to 810 is just times 3. So because I have a multiplier of times 3, this function is exponential. Now, the parent function that we're going to use for exponential functions is just y equals 2 to the x, where the exponent is x. Now we're going to go into linear functions. whenever I was given a table, look like this. Oh, 20, 25. My first difference was constant. Okay, my x's are also constant. Changes in 5. First difference is constant. Because the first difference is constant, we're going to write yes, constant. And then, yes, linear. Okay, the linear parent function is y equals x. This is the parent function. The equation for this function is y equals 2/5 x. That's the equation that'll give you this table. Okay? That's all because the first difference was constant. Now if we had another table, and the y values were 1, 4, 9, 16, and 25, whenever we find the first difference, we get 3, 5, 7, and 9, because from 1 to 4 the change is plus 3, from 4 to 9 the change is plus 5, from 9 to 16 change is plus 7, 16 to 25 the change is plus 9. It's not constant. Because it's not constant, it's not linear. So we have to find the second difference. The second difference we find by taking the difference of the first difference. There's no way we can find the second difference if we haven't found the first difference. So for the second difference between 3 to 5 is plus 2. 5 to 7, plus 2. 7 to 9, plus 2. Because this is constant, so yes, constant, this is a quadratic function. And the parent function, the parent quadratic function is y equals x squared. Okay? Now, our last type we found was a cubic. Remember, a cubic function is y equals x to the third, and we have to use the third difference. So in order to find or determine if a table is a cubic function, we need to find the first difference, and then the second difference, and then the third difference. So, difference between 1 and 8 is 7, and then 19, and then 37, and then 61. The second difference is 12, 18, 24, because the difference from 37 to 61 is 24. 19 to 37 is 18, 7 to 19 is 12. Still not constant. So it's not linear, not quadratic. So we go to the third one. And we get a constant change of 6. That means this is cubic. And the cubic parent function is y equals x to the third.